Yeah, this is Leetcode 560, and this is the subarray sum equals k problem. So we're given some integer array. It doesn't say if it's negative or positive. Numbers. Yeah, it's both negative and positive and zeros as well. And k is equal to 2, and we're trying to find the continuous arrays that sum up to k. So for example, 1 does not sum up to k, 1, 1 does sum up to k, 1, 1, 1 doesn't, and then 1, 1, these two ones also sum up to k, so our answer would be 2 in this case. Right, yeah. So obviously there's a brute force solution to this method where you can just go from, you can just iterate twice and then you'd have to check the sum, so it'd be like a O of n cubed solution. But we're going to be utilizing a dictionary to use our current sum. So we're just going to iterate loop once and then use our current sum to see if we've, or if that current sum minus rk, if we've seen our current sum minus k before, and then we're going to increment our count, our answer as we go on. Oops, that's so dark. That's a little better. Oh well. Yeah, so the idea is to keep like a current sum, and then we have some dictionary that's like our counter, right? And current sum is going to be initialized to 0 at first, and then we're going to have our results, or how many. So we're just getting a count of this, right? Yeah, total number of continuous subarrays. So total, initialize that to 0 as well. Current sum is 0, total 0. What else do we need? That might be good for now. And then what we want to do in dictionary is initialize our first element of 0 to be equal to 1, key and value pair. And you'll see why we do this, but essentially what we're doing is if we get the current sum minus k is equal to 0, then that means that we found a number that equals to k, so we need to increment by 1. So if that doesn't make sense, we'll go over it and then hopefully it'll make sense later. So what we're doing is we're adding to our current sum as we iterate through just this array once. So let's use a better example actually. So let's think of one. Yeah, like 1, 2, and 3, and k is equal to 3. It would be 1, 2, and then just 3. Right? There's other examples, but yeah, for purpose of this, we'll just work with what we have here. So yeah, 1, 2, and 3, and then we're going to iterate through this array. So we're going to do current sum plus equals n. So let me write some of that actually first. Define subarray k or something. Actually, no. When you're doing an interview, you should come up with better names. So let's think a little bit about what we want here. We're looking for the number of continuous arrays that are equal to k. So we'll do like count array k, I guess, continuous array k. Okay, that's not that great, but we'll just work with that for now. I don't think you should spend too much time on that. And you're given some sort of array nums and an integer k. So we'll do what we wrote there. Cur sum equals 0, total equals 0. Should be like total count. I guess you could write total count. D is going to be like a default dict of int, but you can actually just write counter from collections, and that should be very similar, if not the same thing. C is not capitalized there. or you could import. Let's from collections import counter. What did I write define? D. Yeah, so D is equal to counter. Right. And then let's say what I did there is D of 0 is equal to 1. Okay, so we have this and we have this, right? Now I said we're going to loop through our nums. So for n in nums cursum plus equal n. So here we're saying cursum is now 1. And what do we want to do now? So we'll say if cursum minus k in D, 3 minus 1 is not in k, right? But if it was, so if we're like at 2, then we would add to our cursum, which would be 3. 3 is in k. So we'll say total plus equals D cursum minus k. Right, and otherwise what we want to do is let's set D, since we've seen cursum, we need to update it. This equals 1. I'm going to add 1 to it. And then at the end, we would just return total. So let's run through this. So the first iteration I said we have cursum 1, and it's cursum minus k is -2. It's not in D. So we'll set D of just the cursum, not cursum minus k. D of cursum, which is 1 plus equals 1. It was not there, so now it's 1. Cursum was 1, so we do that. Next iteration, we're at 2, cursum plus equals n. 1 plus 2 is 3. Total is going to be, or if cursum minus k in D, 3 minus 3, it is in D. So we're going to add to our total the element of cursum minus k, which was 0. The value of that is 1. So we add 1 to our total. And then we go to D of cursum, 3, just in case we see it again, plus equals 1. So we set that. And then we go to the next iteration, cursum plus equals n, just 3. 3 plus 3 is 6. Right? If cursum minus k, 6 minus 3 in D, well, what do you know? It is there, because we just added it before. And now we add plus 1 to our total, again, equal to the amount of that value. And then we set that cursum equal to 1. And then we return to total since we've iterated through all of n. So we would return just total here. And as you can see, continuous, out of all the continuous arrays, 1 and 2 is equal to 3, 2 and 3 is not, 1, 2, 3 is not, just 2 is not, just 1 is not, but 3 is. So you get 1, 2, and 3, and then the total here is 2. So that is our solution. If you kind of go over the runtime complexity, you're iterating through nums. And cursum, indeed, that's in constant time because we're searching through a dictionary. And the total, so this is just linear time. And then we're storing key value pairs in our dictionary. That's going to be an O of n for each of n that we could possibly see. Yeah, so it'd be O of n and O of n as well for the space time. So there's our solution. Thanks for watching.